So this leads us into DeMoivre. I can't say it, so that says, I'm not French, so if you have any French background, you can say it or you can Google it. So DeMoivre is kind of how I say it, but it's like DeMoivre, something like that. So sorry if I butcher it, but what we're going to do with that theorem is if we have a complex number in trigonometric form, so we have z is r cosine of theta plus I sine of theta in parentheses, what we can do is we can expand z to the power of n. So we can raise this side to the power of n, and if we do that to this side, what it will actually simplify out is to this. So the idea is z to the n to the power of n is equal to this. And that's important because if I say like 1 plus 7i to the 100th power, I can simplify that really fast by using this theorem, because then you only have to do 1, 2, 3 calculations versus distributing this out 100 times, which if you remember what this is like 1 plus 7i times 1 plus 7i times 1 plus 7i, and we can keep multiplying this out 100 times. We keep going and going and going, which would not be fun to do all of this by hand. So we have another way to do that very quickly. So let's go ahead and use this theorem. The first thing I noted is it's to the power of 3. So this will tell us something. We also have it in this a plus bi form. So if we wanted to think about it, this a value is 3, the b value is negative 3 squared root of 3, and then our n to the power of is 3. Again, I don't want to distribute all this out. It's not fun. Even if I put it 30, it's very easy to do. Just takes maybe a little few extra steps, but it's not too bad. It would be a different number, a bigger number, obviously. In most cases, it could be more negative or more positive. Once you have that, we're going to be using this theorem. So the idea is we have this, we want to write z is equal to r times this cosine of theta plus I times the sine of theta. Eventually, we will put it to the third power, but we're going to just do this first. And then we're going to take it to the third power. I like doing this first because we need to find theta and r. So how do I find theta and r? So remember back when we found the radius. So the radius, remember, is just the square root of x squared plus y squared, which we're just going to use a squared plus b squared in this case, in this situation. So we're going to do the square root of 3 squared and then plus a negative 3 squared of 3 squared. Now, if we type that into a calculator, we should get that our value, or my radius here, is 6. Now, again, this would be 9. This squares to this negative 3, which turns into 9, and this turns into 3. 3 times 9 is 27. 27 plus 9 is 36. So the square root of 36 is, in fact, 6. So now we need to find our theta. So if you recall theta, that's pretty easy to find. We're going to just start with tangent. So we know that the tangent of theta is b divided by a. So where is my theta when I have b divided by a here? In this case, theta is equal to that tan inverse of that b over a. Now, if we put that in our calculator, what is theta? Where's tan inverse of? Well, if you think about it, we have b, which is negative 3 square root of 3 over 3, which does cancel out. So where is the theta equal to the negative square root of 3? So let me move this up a little bit. So where is theta equal to this negative square root of 3 on your unit circle? If you remember, that would be down below, going this way, right about here at negative pi over 3. But we want that as a positive angle, so remember that would be 5 pi over 3. Remember, you can add the 2 pi to make it coterminal. So if it's negative right here, you can figure that out, or you could have just went around and found it. That is 5 pi over 3. So that is our theta, which is 5 pi over 3. So just a reminder of what we did. So now we have our theta, we have our r, and now we can substitute those into there. So maybe this is the hardest part of doing it, is just kind of going back to our chapter 4 and 5, our trigonometric chapters, and doing that. So now we can find z, which is our r, which is 6, and then we're going to multiply it by the cosine of 5 pi over 3 plus I times the sine of 5 pi over 3. Now that is z. Now if we wanted to, again, we know n is 3, we're now going to actually take everything to the third power. So now using that theorem, we're going to say, well, we can do z to the third because we're using n is 3, or if it was z to the 7th, we would do a 7 there. We're going to still keep that a 6, but we're going to raise it to the nth power. So this 3 will be that n right here. So I'm going to put that in red, and then we're going to use that theorem again, but we're going to do that cosine of 5 pi over 3, but we're going to be multiplying it by n, which was our 3, and then plus I times the sine of 5 pi over 3, but again, we're going to be multiplying it by that 3 and close those brackets. So that 3, or n, in that theorem will go inside of the theta, so it'll be n theta and n theta for both of those. So let me just rewrite that formula for you. So we have z, to get z to the n, we get equal to r to the n times the cosine of, it would be n theta plus I times the sine of n theta. So what we're doing is we're taking that value of n and putting a 3, 3, and a 3, and a 3 in there. And I just put it on the side here because you could put it in front or back. I just easily wrote it that way. And this is clearly not a 3, but now it is a 3. So now we just have to simplify that, and that would be our final answer. And it's not too bad. So if we think about this, 6 to the third is 216. Cosine, now we have the cosine of just 5 pi, and then we have plus I times the sine of 5 pi, and now we can simplify that even further. So if you think about this, this is coterminal. So as a simplification here, we have 216. This is the same as cosine of just pi. We can subtract out 2 circles. This is the sine of just pi. Again, we could subtract out 4 pi if you're thinking about it inside of there. So just as a thought process, we're not actually writing this down, but just what I'm doing, it's coterminal by taking off 2 circles. Then our last thing is, well, what is the cosine of pi and what is the sine of that? Well, remember the sine of pi is 0 and cosine of pi is 1. We have the x value at pi and the y value at pi. So, sorry, that's -1, my bad. In this case, we get negative 216. This is 0, so that goes away, and that is my answer. So that would be a negative 216 as our final answer. So let's streamline this. So like I said, we want larger values of n to make this simpler. So this is the formula. The first one's a, this is b, and this is our n. Now let's convert this a plus bi form to the n to that trig form. So again, we're going to have to find theta and r, so let's just do that on the right. So again, that's a squared plus b squared. So if we do the steps for that, we should end up getting r is the square root of 16 or 4 if you do that. So hopefully you get that r is 4. And then theta ends up being the tangent inverse of b over a. So in this case, negative 2 over 2 square root of 3. Find that on the unit circle. Do a little bit of work. We end up getting theta is 11 pi over 6. So now we have both theta and we have r. We have to substitute those into this, and we also will plug in n. So in this case, we're going to do z to the 6th power is equal to r, which we just found was a 4, and we're doing that to the 6th power. And now it's cosine of n theta So our n again is 6. Our theta we just found is 11 pi over 6. And then we have plus I times the sine of n theta. Close those brackets. In this case, again, we have n, which was 6, and then our theta was 11 pi over 6. So now we just have to simplify that. So now we have z to the 6 is equal to 4 to the 6, which is 4096. Type it into a calculator. Remember, this is the cosine of just 11 pi plus I times the sine of 11 pi. And then in this case, this is coterminal with just pi again, which is not always the case. So in this case, we have z to the 6th is equal to 4090 times the cosine of pi plus I times the sine of pi, which again, we know that this is -1, this is +1, so this is -1, this is 0, so that goes away. If this one didn't go away, we'd have an I with that, which sometimes will happen, which maybe it would be z to the 5th when you have something like that. So our final answer of z to the 6th in this case, or this number to the 6th, is going to be -4096. So instead of distributing this out 6 different times, we can do it very streamlined and very quick.